Alright, nerds, so today we're going to talk about empirical formulas. Now this is kind of a big deal, and it's a very long process. Well, it's not really, but until you've practiced it a few times, it's going to seem like a very long process. So we're going to do this now, then we're going to do some practices next in class. Alright, so empirical formula. Basically, it gives you the simplest whole number ratio of atoms in a compound. Okay, so again, whole numbers. And it's not the actual formula, it's just, this is the simplest version of it. Okay, so for glucose, the chemical formula is C6H12O6, but the empirical formula, if it's the smallest ratio, remember the common denominator for all of these is, if we go here, the common denominator for that subscript and that one is 6, so they're all divided by 6, which means our empirical formula is CH2O. Alright, so where is this useful? It's useful in macro elements. Now, macromolecules. So, the term empirical, it's part of the process of elemental analysis, and we use it to determine the relative amounts of each element in a chemical compound. Now, this is the standard way we write the formula for macromolecules, and that includes ionic compounds and molecular covalent network compounds. So yeah, so when it's like Si a billion, oxygen 8 billion, like it becomes a bit simpler. Alright, so first we need to remember molar mass. Now the molar mass is the weight of 1 mole of any compound. So for carbon, it's going to be about 12. Alright, so the molar mass of things we find in chemistry pretty much can go somewhere between 18 to infinite, really. The molar mass, we're measuring kilograms per mole. That's the SI unit, but we use grams per mole just because of the sizes we deal with. So the molar mass is found by looking at the atomic mass of the periodic table and then dividing it by, and that's pretty much it, really. So if you want to find the molar mass of carbon, you'd find the atomic mass on the periodic table, and that's the amount of grams per mole of that. Okay, so carbon is 12.01 grams per mole. In other words, 12 grams of carbon is 1 mole of carbon. And remember, mole is this number here of molecules. Okay, so that's pretty straightforward. Go over that. We've done a previous here on that if you're still not sure. Alright, so how to work out the empirical formula. We're finally there. You want to start with the number of grams of each element. Okay, now if you're given percentages, work with 100 grams just to keep it simple. Okay, so we convert the mass of each element to moles using the molar mass from the periodic table. So we convert it to moles. Then you want to divide each mole value by the smallest number of moles calculated. Okay, we'll see what that means in a second. So you work out the moles, how many should go to moles, and then divide everything by that one, by the lowest. Okay, so we then round off to the nearest whole number. If it's very close to a whole number, we can round off. If not, we have to multiply it by a factor. We'll show that in a second. So this ratio we get is, we put those ratios instead of in front of it, so it's not, instead of being C2, instead of being C2O, so twice as many oxygens as there are carbons, we would write CO. We put the little ratio down the subscripts. You've seen it before. That's when it starts to look like a regular compound, regular formula. Okay, so this is what I was saying. If it's near a whole number, round that off. That's fine. So down here, if it's near a whole number, round that off. No dramas. But if it's 1.5, you can't. That's too far away to really round off. So multiply it by 2 to get 3. But you then have to multiply each one. So just say this one here worked out to be CO 1.5. We'd multiply it by 2, so you get CO 3. But if you do it to this one, you've got to do it to this one. So what you actually get is C2O3. So yeah. Alright, so if it's too far away, multiply it to get by a factor, but you have to do everything for everyone. Like, keep everything the same. Alright, so the next part here is 2 examples. So we start off with, so write these down. Definitely the the given parts as we go. So a compound was analysed to find 13.5 grams of calcium, 10.8 grams of oxygen, and 0.675 grams of hydrogen. So we want to find the empirical formula. It's not too hard. Okay, so we start with the given grams of each element. Okay, so that's where it is. So the first thing you do is you write that down. Then you want to convert the mass of each of those elements into moles. Okay, so 1 mole of this is 40 grams, so that's how many moles you've got. 1 mole of this, so remember that's using the formula N for moles equals we'll do it down here so we've got a bit more room. So it's using the formula N, which is number of, so moles, equals mass over molecular mass. Now the one we need is, so the one we know is this one. Now basically another way to write that is M times 1 over, and that's just the way that's been done there. So here it's this times 1 over that, that times 1 over that, and so here we have the mass for calcium is 13.5, that's what we've got, and the molar mass is that, but you can just stick it into this formula here and it will do exactly the same thing. So mass divided by the molar mass. Alright, that's our mole conversions. That's pretty straightforward. We've done that before. Now the lowest is this bad boy right here, so we're going to deal with calcium. That's our lowest number. Alright, so next step was divide each value by the smallest number of moles calculated, and then round to the nearest whole number. So that is obviously 1. That is 2. And this one here, that's near enough that we can round to the whole number. So the mole ratio is going to be Ca, 2 of those, 2 of those. Alright, that's the empirical formula. Now we actually know that it's this one here. But that's the empirical formula. So calcium hydroxide. Alright, that's pretty straightforward. Go over those steps. See, each one was a separate step and it wasn't too bad, but re-go over the steps if you're not sure. It's definitely one we've got to show while you're working. Alright, problem 2. Now we're going to need to know this further down the road. We'll be given percentages here, so let's make each one of those out of 100 grams, and there we go, straightforward. This is NutraSweet. So we've got our givens. Now we convert the mass to moles. Same deal using the periodic table. So again, using moles equals M divided by big M, or that, which is also equal to M times 1 over, and that's where they've ended up. So stick with this one, and we've gone to the same answers here. Now the lowest one there is obviously that one, so let's divide each one by the smallest thing and then round to the nearest whole number. So we've got 7, 9, let's have 1, and then 2.5. We've got a problem now. We can't round that off. That's too close, too far away. So we've now got to round it off. If we times that by 2, we get 5, but if we multiply that by 2, we need to multiply all of these by 2. Alright, so this gives us the empirical formula of C14H18 and 2O5. Now, we know the molecular formula, so we can work that out by doing a ratio. Okay, so from periodic table, we know we can work this out. That is the molar mass. Okay, so if that's it, that's the molar mass. This is our empirical formula. Okay, this is the molar mass as it was given to us in the beginning. So if we divide those, it's close enough to 1, which means the empirical formula that is there. The molecular formula is as it is there. If this answer was 2, well, our molecular formula becomes C. What's that? 28 H 36 N 4. Oh, this is annoying. Sorry. And O 10. Okay, we've got quite a large molecule, but for long chain hydrocarbons, that's actually not that big, and that'd actually be a protein, because it's got, you can tell it's a protein because it's got the nitrogen in there. So yeah, alright, so that's empirical formulas. Oh yeah, clean my writing off and show you. So that's empirical formulas, and now it's the molecular formula as well. Alright, I hope that wasn't too much. You might need to go over some of those steps, but write down those steps and we'll go through them with some questions in class.